Okay, so this is the Mr. McGehee electric field worksheet. 5 and 6 are, I think, the toughest ones on the worksheet. So here's number 5. So we have charge Q and Q2. So here's our given information. We got Q and then Q2 located at 0 and X equals 3.5, like right there. So I'm gonna diagram this down here. So we have charge Q, and you know what? I'm gonna take the liberty and call this QA, just so we can talk about it. Charge A, QA is equal to positive 0.02 coulombs, and then over here we have charge 2, which is negative. We're going to label this guy Q2, negative 0.05 coulombs, and the total distance of separation is 3.5 meters. Okay, determine the magnitude and direction of the total electric field at X equals 2, which would be, I don't know, right around in here, a little bit before the midpoint. Okay, so we're finding the total electric field at this point right here. Now, first thing you got to do is you got to realize that electric fields are vectors. They have direction. Now, in this problem, are these two charges, is this guy and this guy a big guy or a little guy? And when I say big guy, I mean the source of the electric field. When I say little guy, I mean the charge that goes into the field and experiences a force. Are these big guys or little guys? They're big guys because they're creating the field. It's from the context of the problem. Determine the magnitude and direction of the total electric field. So just the way the question is worded, these guys are creating electric fields. Now, what's the definition for the direction of the electric field? The direction of the electric field is the direction that a little positive guy will experience a force. So if you put a little positive guy right here, which way is the force on that guy? Away. So in general, electric fields go out from big positive in all directions like this. So I'm showing the electric field lines around this charge. So what's the electric field line from this guy doing at the point we're focusing on? Is it going to the left or to the right? To the right. So we have an electric field from charge A. So we're going to label this EA because I'm calling this guy charge A. So the electric field from charge A goes to the right. Now, we have a big negative. What do we know about the electric field around big negatives? It goes in. Why does the electric field go in? Because that's what a little positive would do, right? The direction of the electric field is based on what a little positive guy would do. So what's the electric field from charge 2 doing at this point we're focusing on? It's going to the right. It's going in to charge 2. So that's the electric field from charge 2. So are these going to add to each other or subtract? They're going to add. So next thing is we find the electric field from charge A at that point, and then we find the electric field from charge 2 at that point. Now what's the equation for finding electric field? E equals KQ. Actually, I'll make that a big Q. This is big guy. KQ over R squared, where that's absolute valued. And you should understand why this is absolute valued, because what is plus and minus in physics? It's direction, you know, so knowing if you have a positive charge or a negative charge, that alone is not going to give you the direction of the electric field. Notice up here, when we were figuring out these directions, we had to look at the situation. So charge is absolute valued. So finding the electric field from charge A, we're going to go KQA over R squared. Oh, and the R from here, so let's redo our distances. So the total distance is 3.5, but what's the distance here? That must be 2 meters. What's this going to be? Oh, I really didn't do this to scale. I messed up there. You know what? This should have been more to the right. I messed up. Yeah. Okay. So here's what you do. K is a constant, 9 times 10 to the 9th, Newton meter squared over Coulomb squared. Charge A is 0.02 coulombs. This is 2 meters, and then you square that. Okay, same thing here. So this is going to be K Q2 over R squared. So you go 9 times 10 to the 9th, oops, Newton meter squared over coulomb squared. And then this is 0.05. And then this is going to be 1.5 meters squared. So the answers here, you get 4.5 times 10 to the 7th Newton per Coulomb. And then this is 2.0 times 10 to the 8th Newton per Coulomb. Are we going to add these two together or subtract them? You add them together. Why do we add them together? Because they both point in the same direction. And then that gives us this final answer. You add them together, you get that answer. Sure. Okay, any questions on this one? Does that make more sense?
That's kind of like the 6 one.
It's very similar to 6. Let's take a look at 6 now.
But could you leave that up for a second?
Well, sure. I'm recording this. Okay. So let's look at number 6 here. So I'm going to get rid of 5 and we'll focus in on 6. Okay, now this one leads to a little bit of algebra. Okay, so this question, very similar. So now we're dealing with Q, which again, let's just call it QA so we can talk about him. And then Q1. Okay, so they're located at 0 and 5. So they're 5 meters apart. Determine the coordinate of the point where the electric field is 0. Okay, so let's draw a picture down here. So here is, I'm going to call this guy QA. So QA is 0.02 coulombs. And then over here, he's positive. So positive charge, we're going to call this guy Q1. And he is 0.01 coulombs. And the total distance of separation is 5 meters. Like that. Okay, determine the coordinate of the point where the electric field is 0. You know what an easy answer would be? And McGehee didn't specify this. What's an easy answer? You could say, oh, the electric field is going to be 0 where? At infinity, right? Because E equals KQ over R squared. If you were to take this situation here and travel a distance of infinity, what's going to happen to the electric field if you move to infinity? It goes to 0. So very frequently these questions will say, determine the coordinate other than infinity. You know what I'm saying? So anyway, we're going to find the actual point. Yeah, we're not going to take the easy way out. So let's take a look at where this could be. So we're going to look at 3 regions. So where are the 3 regions where the answer could be? The 3 possible regions would be over here somewhere, in the middle somewhere, or over here somewhere. Only one is possible. 2 of them are not possible. So let's look at why. So let's take a look at the region to the left first. Could the answer be somewhere over here? Absolutely not. Let's look at why. Okay, so electric field for positive charges go where? Out, like this, in all directions like that. So both of these guys are sending electric fields in the outward direction like that. Okay? Now, so if we go over here to this point, what's the electric field from charge A doing? Going to the left. So we have electric field from charge A. Okay, what's the electric field from this guy doing? Charge 1. To the right. Is there any possible way for these 2 electric fields to cancel each other? Never in a million years. Because why? Charge A is bigger than charge 1. So, so charge A at this point has 2 advantages. What are the 2 advantages? He is bigger and he is closer. Does that make sense? So this electric field is going to be larger than this electric field anywhere to the left of our situation. Now how about if we go over here to the right, if we look over here? So let's pick a point over here. Is it going to be possible over here? So the electric field from charge 1, the electric field, this is Q1 right here, is going this way. So we're going to call that E1. Is the, which way is the electric field from charge A going? It's going this way also. Are those ever going to cancel? Wait a minute.
On the left side, both.
Dudes.
They have to be in the middle.
You know what? I totally blew it here. Back the truck up, dude. This is, hey, nobody called me on this. I made a mistake. Stop.
Hey, no, we're human.
Look. Dude, what was my mistake over here? They're both going the same way, dude. Back the truck up. EA is going that way. E1, they're both going to the left. You guys get it? Look, how many of you caught my mistake? You got to tell me, dude. Look at the electric field from A going this way. They're both going to the left. Okay. But kind of what I was saying about the size of the charges, that is something you want to look at. That would be if this guy were negative. If this guy were negative, then you would have been doing what I said. Okay, so pick a point over here now. So which way is the electric field from A going? They're both going the same way. So they're never going to cancel. Ever, ever, ever. So now you pick a point somewhere in the middle. Is it going to be closer to charge A or farther from charge A? Farther, because charge A is bigger. So it's going to be a point like right here. Okay, so the electric field from A is going this way. The electric field from charge 1 is going this way. If the electric field, we want the electric field to be 0. So what must these two electric fields be doing? Canceling. They got to be canceling. Now we got to set up our distances. We're going to call this distance right here. Dude, you're creeping me out. We're going to call this distance x. Okay, that distance is x. So what's this distance going to be?
5 minus x.
5 minus x. Okay, those are our distances. So now, what we want to have happen is we want electric field of charge A to equal electric field of charge 1. That way these two will cancel each other. So now what you do, okay, so I got to make some room here. Let's shrink this down so I have some room. Okay, so now what you do is you go like this. So what's the equation for electric field? K, QA, and then what's the distance for charge A? That's going to be x. Square it. And then this is going to equal K, Q1, 5 minus x squared. The k's cancel. And then you're going to get this equation that looks like this. Then you're going to cross multiply. This turns into some algebra. QA 5 minus x squared equals Q1 x squared. Now here's what I would do. First of all, QA is what? QA is 0.02. Q1 is 0.01. So this is going to simplify down to 2, right? 0.02 divided by 0.01. That's going to be 2. 5 minus x squared equals x squared. Take the square root of both sides. Square root both sides, you're going to get 5 minus x multiplied by square root of 2 equals x. Keep going from here. You guys are good at algebra. X comes out as 2.9. So that's where it's got to be.